Hello everyone, this is Vipul Purohit and I welcome you for another edition of Chemical Kinetics. My dear friends, if you remember in the first session, we had discussed about the complex reactions which are taking place. Primarily, there are three of them, and those were reversible reactions, consecutive reactions, and parallel reactions. Now, in this segment, we are going to talk about thermal chain reactions. Now, when I talk about chain, it's going to be continuous, successive, one after the other. So it takes place in series of successive steps, which involves reactive intermediates, which can be either in the form of atoms or free radicals before the final product is formed. And hence we can say that these reactive intermediates are those species which are generated in one of the step and then it is consumed in the successive step, and this process takes place continuously, and hence we can term these reactive intermediates as chain carriers. Basically, these reactions takes place in presence of heat, and hence we call them as thermal chain reactions. These reactions primarily involves four important steps. Step 1 is known as chain initiation. Initiation means, my dear friends, you understand that it's going to be the beginning. In this particular step, the reactive intermediates, which I said earlier, it can be either in the form of an atom or free radicals. They are going to be produced from ordinary reactant molecules. Now here I would like to clarify that when I talk about atoms, now most of you feel that atoms are going to be stable. But then there are certain species who exist in a bimolecular form. Generally the gases, hydrogen, chlorine, oxygen, nitrogen, fluorine. But if they are in a monoatomic form, then they become unstable and they behave as reactive intermediates. Alright? So this is step number 1, chain initiation. We move to the second step, that's called as chain propagation. Propagation means it's about increase in the length of the chain. Now in this step, the intermediate which is going to be formed in the initiation step reacts with the another reactant molecule, resulting in the production of a new intermediate. Now this basically is a continuous process, okay, and it goes on repeating several times, which, as I said, is responsible for the increase in the length of the chain. We go into the step number 3, that's called as chain inhibition. Now see what happens is, it's a simple part, and that is, if you're driving a car very fast and suddenly if you put a brake, then there are chances that the car may turn upside down and result in an accident. So the best way is that before putting a brake, you need to deaccelerate, that is, reduce the speed. And that is what the same thing is over here. During chain propagation, the car is being driven with a very high speed. Now somewhere or the other we have to stop this process, isn't it? So directly we cannot put a brake. We have to first of all lessen the speed of the reaction, and that is what happens in chain inhibition. So it is this step in which the reactive species will attack the product molecules which are being formed, and thereby the rate of the reaction decreases, retarding the reaction. That is what it is called as. And now once the speed of the car is lessened, now you can put a brake. So the car comes to a standstill without any accident. And that is, my dear friends, the last step, that is chain termination, in which the reactive intermediates are removed, resulting in the termination of the chain. So, my dear friends, this entire process is being explained with respect to an example, the illustration of which is between hydrogen and bromine, resulting in the formation of hydrogen bromine. So H2 plus Br2 gives you 2 molecules of HBr. The reaction takes place in a temperature range of around 200 to 300 degrees Celsius. So let's now understand the mechanism of the reaction. In step 1, the diatomic molecule of bromine breaks down and it results in the formation of 2 bromine atoms. This is the initial step. This is also called as chain initiation. The rate constant for this is given as K1. Next step, one of the bromine atom which is being formed in step 1 reacts with the another reactant, that is hydrogen molecule, resulting in the formation of hydrogen bromide and a hydrogen atom. This hydrogen atom in turn behaves as a reactive intermediate and which will react with another bromine molecule, which is also a reactant, resulting in the formation of hydrogen bromide and bromine atom. So this step will correspond towards chain propagation. That is step number 2. Actually, in terms of reactions, they are considered as step 2 and 3. But the 4 steps which I spoken about, so with respect to that, both these reaction constitutes chain propagation. Now, as I said earlier, the car is in full speed. I cannot put a brake right now. So I have to retard, I have to deaccelerate, I have to slow down the rate of the reaction. So in the next step, the hydrogen atom which is going to be formed during chain propagation will react with the product molecule, that is hydrogen bromide, resulting in the formation of a hydrogen molecule and bromine atom. So the formation of a stable hydrogen molecule will deaccelerate, will retard the rate of the reaction. And then the last step, whereby when the rate of the reaction slows down, then we can put a brake. So the 2 bromine atoms combine, resulting in the formation of a stable bromine molecule. And that is chain termination. So my dear friends, you can check it out. The hydrogen and the bromine atoms are reactive, short-lived intermediates because they are unstable. So obviously their life is short. They are regenerated and consumed several times during the course of the reaction. Hence, the bromine atom or hydrogen atom is responsible for the production of several HBr molecules. So I guess, my dear friends, with this particular illustration of the formation of hydrogen bromide, you all must have understood the concept of thermal chain reaction. All right. So thank you so very much for your patient listening. And until we meet next time, do take good care of yourself. Bye-bye.